My dear friends, welcome back to my YouTube channel ADC Maths. In this video, how to solve the first order partial differential equation, and particularly the f of p comma q equal to 0 type. For this type, we assume z is equal to ax plus by plus c be a solution, isn't it? Let us see this problem. The first one is solved. Root x, that is root p plus root q is equal to 1. So given PD is root p plus root q is equal to 1, is equation number 1 is of f of p comma q equal to 0 type. So the first step is to identify which type is this. And for this type f of p comma q is equal to 0 model, the assumption to get the complete integral is z equal to ax plus by plus c. This is equation number 2. Still there are 3 arbitrary constants, so our aim is to minimize into 2. So now differentiate this 2 with respect to x and y, we get dou z by dou x equal to a, otherwise p equal to a. Dou z by dou y equal to b, otherwise q is equal to b. Now see, let us substitute the value of p is equal to a and q is equal to b in the given partial differential equation number 1. We will get root a plus root b is equal to 1. So from this, root b is equal to 1 minus root a, otherwise a or b is equal to, by squaring both the sides, 1 minus root a to the whole square. So I found the b value in terms of a. Usually we can do the other way, root a equal to 1 minus root b, so a equal to 1 minus root b whole square. That is also correct, right? Now after getting the b value, once again substitute the b value 1 minus root a to the whole square in the equation number 2. I am getting that z is equal to ax. See that equation number 2, z equal to ax plus b. What's b now? The b is now 1 minus root a to the whole square into y plus c. Now can you count the number of arbitrary constants? A and c only 2. There are equal number of arbitrary constants and the independent variables x and y. So this is the required complete integral. So this is the required complete integral. Why it is the complete integral? Since there are equal number of arbitrary constants and the independent variables. Right, sir? So this is the way to get the complete integral. What about the singular integral? To find the singular integral, so from the equation number 3, I am going to differentiate the equation number 3 partially with respect to the constants, a and c, and equating it to 0, and equating it to 0. Why we equating it to 0? Because z is the function of x and y only. So when we differentiate with respect to a or c, it is equal to 0. So when I differentiate this with respect to a, dou z by dou a equal to 0, simply write the equation dou z by dou a equal to 0. No need to show the differentiations, not necessary. But what about dou z by dou c? See that c is a separate constant. When we differentiate with respect to c, we get 1, and when we equate it to 0, this equation we get, it is 1 equal to 0. 1 equal to 0 is correct? No, sorry, which is a fallacy, which is a contradiction to the number theory, or which is absurd. So that's why there is no singular integral. There is no singular integral for this type number 1. So any questions comes at type number 1, only this much is fixed. Here only it is varying, and after that c is anyhow it is separated. So this is the same idea for entire type number 1. So what about the gi? The gi, let us take c be the function of a in the complete integral number 3. We get is z is equal to ax plus 1 minus root a to the whole square into y plus the phi of a. Phi of a, this is number 4. Let us see that equation number 4 is only in terms of a. Now once again differentiating equation number 4 with respect to a and equating it to 0. And equating it to 0. What we will get? I don't want the differentiation. I simply write dz by dA equal to 0 is number 5 now eliminating the constant a from 4 and 5, if it exists, we get the required general integral, right? From equation number 4 and 5, if it exists, we get the required general integral. So that's it. So this is the type number 1. This is the type number 1 model, that is f of p comma q is equal to 0 model. Once again, I would like to go for the second sum. Suppose the given PDE is, this is equation number 2, this is problem number 2, p squared plus q squared is equal to npq. What happened? Sorry, n is a positive integer. N is a positive integer. Got it? P and Q are the first order partial integer. So other than the P and Q and N, nothing was there. So this comes under type number 1. So this is my equation number 1. So the given PDE is P squared plus Q squared. P squared plus Q squared is equal to NPQ. This is equation number 1 is of f of p comma q equal to 0 type. So to find the complete integral, once again the same idea. Z is equal to ax plus by plus c. Differentiating with respect to x and y, we get p equal to a, q is equal to b. Now substitute p is equal to a and q is equal to b in the given PDE. We get what we'll get. Let us see. A squared plus b squared is equal to NAB. Otherwise, my aim is to get the b value in terms of a. So b squared minus na into b plus a squared equal to 0. This looks like a quadratic equation in terms of b. So I need the b in terms of a. So what's the quadratic formula? Minus b plus or minus square root of b squared minus 4ac by 2a. So the same idea here. The coefficient of b squared is 1. Coefficient of b is na minus na. And the constant term is a squared. So from this, by using the quadratic formula, we get small b equal to minus of minus na plus or minus square root of minus na to the whole square minus 4 into a into 1. This is a square into 1 by 2 into 1. So it's equal to minus or minus plus na plus or minus square root of n squared a squared minus 4a squared by 2. Otherwise, by taking the a outside, because a squared becomes a from the square root. So a outside, n plus or minus square root of n squared minus 4 by 2. So this is the b value. Now substitute the b value in equation number 1. In number 2 we get z is equal to ax plus, what's the b value now? This one, n plus or minus square root of n squared minus 4 by 2 into a into y plus c. So can you count how many constants are there? 2 constants, that is a and c. So there are equal number of arbitrary constants. So that's why this is called the complete integral. Since there are equal number of arbitrary constants under the independent variables. So got it? Then from this complete integral, eliminate the a and the c once again. But anyhow, c is a separate constant. So once we differentiate this with respect to c, we get it is 1 equal to 0, which is a fallacy, which is a contradiction to the number theory. So there is no singular integral. And to take c is a function of a, to eliminate that constant a as well, we get the required general integral. So this is the idea behind this type number 1 partial differential equation, type number 1 f of p comma q is equal to 0 model problems. I hope you may understand this type number 1. Let us see the other types in the other videos. Please kindly subscribe to my YouTube channel ADC Max and get a notification button so that you can get the new videos once it is uploaded in the YouTube. Thank you so much.